skipping chapter 4 for now because of the fact of ACT. Okay, I do not know if they're going to come steal my calculators, and if they do, you really need calculators for chapter 4. So we're going to skip over it. We will go back, and I dread it because I hate it, but we'll manage. Okay, so we're now going to get into the graph parts of this. Okay, this is not your typical graphing. We're not graphing -4, 3. Oh. We're not finding the slope of a line. Okay. We're not doing any of that. What we're going to look at now is routing problems and how to get from one place to the other the fastest, most optimal route. So this entire section is on management science problems. And what we're going to do is we're going to work on finding efficient ways. What does it mean to be efficient?
Like work really good.
Okay.
Perform at a high quality.
Perform at a high quality. Okay. So we're going to find efficient ways to organize and carry out a large number of tasks that do not often appear possible to make optimal decisions. So, like I said, we're going to start with routing problems. So our job in this chapter is to find ways to route or send. Route or send the delivery of goods, services to an assortment of destinations. So you're looking from this perspective of being like a postal service man. Okay? You're looking for the fastest, most efficient route to drop off mail to all of your houses in your neighborhood. Okay? Or you're a UPS driver. Okay? You've got to pass off packages to this large area. What's the fastest way they can do that? Okay. So we'll be able to answer questions like, is there even a route possible? Can you even do it? Okay. You may or may not. And if there are multiple ways, which one is optimal? So we're going to start looking at graphs. And a graph in this case is just a bunch of dots and lines. Okay. So your dots are kind of like your places, and your lines are the ways you can get there. Okay. So that will lead us into our key terms then. Okay. So key terms of a graph. First things we have. This is an example of a graph. Okay. The first things you have are what we call vertices. And these are the dots of your graph. Okay. So name me a vertice. A. Give me another one.
D.
B.
B.
E.
E.
C.
F.
There's no F there.
Z.
So these are all of your vertices. Bless you. Okay. We also have something called a vertex set. Well, that is just all of your vertices written together. Okay. So if they're asking for a vertex set, all you're doing is listing the names of all of your dots that are on your graph. We also have edges. Your edges are just the lines or the curves that connect your vertices. So the easiest way to label your edges is to cross them out as you do them. So I have one line that connects my points from A to B. So we label that edge A, B.
Yep.
It's the two dots it connects. Now, can you switch it and write it as B to A?
Yep.
Absolutely. Okay. A to B and B to A are exactly the same thing. Okay. I have a line that connects to A to E. I've got one that connects A to D. Now, be careful. Look at E and D. How many lines do you have to connect those two? There's two of them. So yes, you must list them twice. So you're going to list ED and ED. You have to represent both lines. We also have one more special edge. And it goes from B back to B. So you label that as B, B. Please do not label it as B and just B, because I'm going to assume that that is a vertice.
BB.
All of it.
Okay. So when you list all of your edges together, that is called your edge set. So your edge set is just a listing of all of your edges. Pretty simple so far, right? Okay. If I told you loop and you're looking at this graph, why?
It's a circle.
Okay. It's not always going to be a circle. You can see a loop that looks like this.
Okay. Basically just goes back to next to his.
It just goes back to itself. So it doesn't necessarily have to be a circle per se. So this is an edge that connects a vertex to itself. Okay. So as long as you have a line that comes out of the vertex, doesn't touch any other vertex, and goes back to where it started from, it is considered a loop. Okay. So I can do a loop that looks like this. I can do a loop that looks like a squiggly blob. Okay. All of these are considered loops. Okay. Your next definition is a multiple edge. D and E. Okay. I've got 2 points. And how many lines did you tell me connected those two? 2. So a multiple edge is 2 or more. So there could be 3. There could be an extra one here. Okay. 2 or more edges that connect 2 points. So ED here is considered multiple edges. Your last one for this, okay, is an isolated vertex. And that is C. An isolated vertex definition. A vertex with no edges.
No edges.
Okay. So it's just a dot with no lines coming out of it. Questions? Okay. So now, of course, we're going to practice.
Oh, my bad.
Okay. I'm going to do the first 2 examples with you, and then I'm going to let you try the next 2 examples on your own, and then we're going to go over it. And then we're going to do some drawing practice, and we're going to be done.
Thanks, Boo.
Okay. You're welcome, Boo. Okay. If I ask you, look at graph 1 and give me your vertex set, what does that look like? A, B, C, D, and E. Again, it's all the letters that represent the dots in your graph. It's getting hot in here, so I'm going to open up this door. Or maybe it's just me because I'm here. Okay. All right. To list your edge set, again, the easiest way to do it is to cross off or mark your lines as you write them out so you don't miss any or double up on any, because you will lose points either way. So I have a line that connects A to E. So I mark it and write it down. I have a line that connects A to B. We have a line that connects B to C. Not B comma C, B to C. I have a line that connects C to E. We have one that goes from B to E, B to D, E to D, and then finally my last one is my loop that goes from D to D. So now they want to know, do I have a loop in my graph?
Yep.
Yes, it's what? D to D. Do I have any multiple edges in this group? Are there any two dots that have more than one line connecting the two dots? Like I have 4 different ones coming out of B, but are they going to the same place? No. So there are no multiple edges here. There are none. And then the last one, do I have an isolated vertex here? No, there's none of those either. Okay.
Wait, so all of this is identifying?
Yep, we're just identifying the key terms from the graph. Okay. And then the next set, I'm going to give you a scenario and you have to draw me the graph. But your graph doesn't have to match mine and it doesn't have to match his. Everybody's going to look different. It's not hard, I promise. Okay. Graph number 2. List out my vertex set. M, N, O, P, Q, R. And yes, I have a thing about putting stuff in alphabetical order. So you don't have to, but my OCD kicks in and I have to. It's just a necessary thing. Okay. So give me one of my edges for my edge set. You said what? I got way too many shouts at once. M, N. M to N.
M to Q.
M to Q. M to N. Another M to N. I've got 2 of them.
Oh, I'm writing it.
So guess what that is?
Multiple edges.
That's a multiple edge. So you can jump down there and write M to N. You wrote it twice up here, so it's a multiple edge. What else do we have? Yes. Yes, go. Go do whatever you need to do, my friend. Okay. You said P to O. P to O. P to M. Q to P. And Q to O. Okay. Do I have any loops in this picture? Does M go back to M?
Oh.
No, it can't go. Just because this looks like a circle here does not make that a loop. Okay? Because it leaves M and goes to a different point before it goes back.
Right.
So there is no loop. What about isolated vertex?
R.
R. Fantastic. Take a couple of minutes and look at graphs 3 and 4.
Why
And
gotta
see
be
what
so?
you can do those. Oh my God. Oh, it's not that bad.
I have a question.
Yes.
So you said how M is not a loop because it stops at N?
Right.
And how is on the other one, how is D a loop? D. Oh, I didn't. My bad.
Because this doesn't touch another dot before it goes back to D. Does that make sense? Okay, good question. All good? Fine. If it's ever an emergency, just go and we'll deal with whatever later. Not a big deal. It's not like any of y'all are just running out to the skip class. Yes. No. That's multiple edge. Multiple edge, because it's not going back to the same point. But you have two lines that connect.
That's easy.
There are 10 lines here. 2, 3, 4, 5, 6. You're like 6. Learn them as you write them. You're not listening to anything I'm telling you to help you.
Oh, CF twice.
And when you get cocky about it because you think you can just do it without using my tips and tricks, it's gonna mess you up. No, it's just a multiple edge. A loop only goes from it back to itself. So since it connects C and F, it's considered a multiple edge because there's two of them.
I did that. Oh, I do BD. Oh.
Also, now that soccer season has started and I've got home games and everything else, every week when you come in, I'll have my tutoring days for the week up on the board. So this week I can do Tuesday, Thursday, Friday.
How many days does it say that we got? And y'all got a game Wednesday?
Yeah, it's away.
All right,
Central. Yes, any days you stay for tutoring will count as negative days. Absolutely. Huh? Tomorrow? Yes.
Can I step out into some space? I got some I gotta
I thought you said sweater. Oh, you got some fun out there.
We ready to look at graph 3?
Yes.
What does my vertex set look like for graph number 3? A, B, C, D, E, and F. Okay. What does my edge set look like? And again, write them and cross them off.
A.
So you said A to B.
Hey.
Okay. So that's this line. We've got AA. So that's here. You said CF twice.
Oh.
So watch. We've got one that comes the whole way around.
Right.
And this one that comes down here. And yes, you need to write it twice. Because you just wrote it twice, where else does that go? Multiple edge. Okay. What else do we have? DE 3 times. DE, DE, and DE. You've got this one across the top, this one in the middle, and this one at the bottom. So that is also a multiple edge. Okay. What else do we have? B to C. B to D, and D to F. Okay, did I have any loops?
Yeah.
Yes, A to A. Even though it doesn't look like a loop per se, it is considered a loop here. And do I have an isolated vertex?
No.
Nope.
Do number 4.
Okay.
That's really it.
Number 4. What's my vertex set look like?
Z, B, W, Y, X.
U, V, W, X, Y, Z. Okay, edge set. U to U, that's my loop. So I'm going to write that down with my loop. U to Y. You said what? U to Z. X to X.
Z to Y.
That's also a loop, so I'm going to throw it down there. You said Z to Y. Y to X. And Z and X.
If you want to be creative, you can do.
And if you want to get creative, you can do what? I'm so confused. Do I have any multiple edges here? No, there's none. What about isolated vertex? B and W. Okay. Question.
Is that really it?
For this section, yes. Okay.
She wasn't.
5.2 drawing examples. Yes, you are going to have to draw on your test. But watch. These are really easy. Okay. So they give you some scenarios here. Number 1 says we have a vertex set. That's what they give you. A, B, C, D, and E. What this means is I have 5 dots to my graph. Put dots anywhere you want and label them A, B, C, D, and E. Anywhere you want. Okay? You can put them all on a straight line. It does not matter.
That's exactly what I was going to do.
That's fine. I'll do one here and I'll do one on the whiteboard too, so you can see that it doesn't matter. Okay? So, yes, you can put them in a straight line. A, B, C, D, and E. Just like that. Okay? It doesn't matter. Okay? Now, just pay attention to the edges they want you to draw. Okay? So, they want an edge that connects A to B. So, draw it. Okay?
B to C.
Okay? They need one that goes from B to C. So, draw it in. Okay? Also, you can cross them out as you're drawing them so you don't go back and double up on something you shouldn't. We need to connect C to D and D to E. Y'all just saw that, right? What the
I didn't see it. Can you do it again?
Sure. Ready?
Oh, I
do
think
it.
that done before. Yeah.
There you go. Okay. So here's, and that's all there is to it. So I've got one graph on the board here. I've got this graph on the whiteboard here. Okay. Victoria's probably doesn't match either one of them. Okay. Saphira's probably doesn't match either one of them either. That's okay. There are multiple ways to do these. Okay. So number 2, how many vertices should I have? I should have 5. A, B, C, D, and E. A, B, C, D, and E. Okay. And then just go through and draw your edges as they give them to you. I need to connect A to B. So there's a line that connects A to B. I also need to connect A to D. Well, I can take it. There's A to D. I need to connect B to C. Straight lines work. You can do curved lines. You could do really weird shapes. I don't know. C to E. I can go like this. And it still connects C to E without going through another point. So that's okay. I need to connect C to D. I need to connect D to A. And I need to connect D to E. Just because because your graph doesn't look like my graph does not mean it is wrong.
So since there was A to D and a D to A, is that not a loop?
No, that's a multiple edge. Yes.
Okay, I don't see.
So I did A to B down, or A to D down here, and I did A to D up here. Okay. So yes, Natria says I have A to D and D to A. Yes, that is a multiple edge. Even though they wrote it D to A instead of A to D, it's still connecting the same two dots. Okay, so it is still considered a multiple edge. Okay. All right, go ahead and do 3 and 4, and I'm going to get one of you up here to do each one. Okay, and then we're going to talk about the 3 at the bottom, because while they are still drawing, it's a little bit different because they don't give you the vertex set or the edge set. They kind of let you do your own thing. And once we're done with these, we are done for the day with notes. Like I said, you have no homework.
So, swear to God.
I want to play catch up on whatever you need to play catch up on since progress reports are due on Wednesday.
The other 6 homework assignments. Oh my.
As of right now, everything that has been turned into me is in the grade book.
Ms. Smith, you made my day.
I'm glad.
No homework. Every day.
Fair. Whose fault is that for getting so far?
I'm just saying, like,
behind,
give the people that turn all their stuff in, like, you know, a
Brian? Like
reward.
the good kids, like.
Yeah. I mean, I'm not a bad kid.
No, you're not.
No homework. That's the perfect one.
Those of you that are taking ACT tomorrow, I'm really hoping you'll be back before 4 o'clock. I know I've got Andy out, Lewis out, Ashanta out, and Michael out tomorrow.
I don't think we went last year till like 1 o'clock.
Okay,
Yeah, we should be.
that's right.
That's what
Yeah,
I'm saying. We should.
you should be back before. And then I lose. You test Wednesday, right? I wrote it down on my calendar.
I'm almost saying.
Not your name on that list, G.
No.
So we got this. Wait, I'm a junior. I'm not taking.
No, Alexis and Rain's test tomorrow. And then I've got Sakaya and Xavier from 3rd block testing Thursday. I just want you to take it again, Trey.
Oh, okay.
Go for your second round.
I blazed with that man before.
Did you?
Yeah.
What'd you get on it?
Man, I don't know.
You know what you made?
Man,
No, on the whole
Who wants to
set.
go up and draw graph number 3?
Me?
God.
I lie.
Come on.
Nah, my drawing's too exclusive.
I'll get the next one.
It's crazy.
Okay.
I'm gonna bring that.
Oh.
Trey doesn't get along with my board.
I swear to God.
So this is left.
Why you drawing so big?
This is long.
You don't even need your paper.
Oh.
Alright.
He gonna copy.
We need Tom.
Except for
He's just trying to help you out.
And take the S.
Perfect.
That's exactly how mine looks. That's crazy.
Swear.
I swear to God.
Why don't you get up and do it then?
Perfect. Mr. Burleson's gonna come up and do number 4. That's for me, that's why I was gonna do 4, right?
Oh, yeah. Man, not too Right, you too.
That's what I was like.
Yeah.
No, I said, are you okay? She said, yeah, most active. Earlier, she had said, like, what? That's actually fine out there.
Good. Question. Okay.
How you doing?
What's going on? What's going on?
Hey, Gary Pitt.
I'm gonna take discrete math with me.
Yeah.
Why? We get to do fun stuff like this.
There's a lot of stuff in there too.
Well, what you taking?
I
Oh, well, that's fine. Discrete math is your senior math. I'm senior next year. We eat cookies and Pop-Tarts.
Sophomore.
Okay. Oh, that means
Yeah,
you
you
go
got
to
two
freak
music
out.
too.
You too smart. Never mind. Go to freak out. That. Okay. So these ones, they just don't give you specifics. You're still going to take it one step at a time. So the first thing it says we need are 5 vertices. You need to draw yourself 5 dots. Okay? Doesn't matter. You're not labeling your dots. You're not doing anything with them. You're just drawing 5 dots to represent your vertices. Now, you need 10 edges. I need to connect these with 10 lines. So just count them. 1, 2, 3, 4. You can make multiple edges if you want. It doesn't say. So you can make multiple edges. You can make loops. You can make whatever you want. So I've got 4. Here's 5. Here's 6. Here's 7, 8.
That looks like ice cream.
9, and 10. Okay. Your lines can be whatever you want. They can be loops, they can be multiple edges.
Should just be 5 loops.
Okay. Somebody last period did it like this. 2, 3, 4, and 5. And she did 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
Oh, that's creative.
Okay. It doesn't matter. That graph and that graph, they still represent 5 vertices, 10 edges. Okay, so moving on to number 6. Start at the beginning. We need 4 vertices, 4 dots. Okay, now it says we need 1 set of multiple edges. Okay, so I need at least 2 lines that connect 2 dots. There's your multiple edge. Okay. The last thing it tells us is we need 6 total edges. Well, when you drew in this multiple edge, you already drew in 2, so we need 4 more lines. Just be careful. You cannot create any more multiple edges because you only need 1 set. Now, I can draw an extra line here to make that still 1 set of multiple edges. So there's 3, 4, 5, and 6. Okay. Just make sure you do not create any more than 1 multiple edge. Your last one then. We need 5 vertices. Okay. One of these needs to be isolated. So pick one and do not draw any lines coming out of it or to it. Okay. I need 2 loops. So here's 1 loop. Here's 2 loops. Okay. These also count for your total edges. So you already have 1, 2 edges. Here's 3, 4, 5, and 6. So I've got my isolated vertex, 2 loops, and 6 total edges. Any questions?
You can cheat on this.
Why would you want to? It's not bad.